Then the length of the base would be 2x. They tell me that material for the bottom costs $10 per square meter. So if we're going to construct this container, the bottom costs $10 per square meter to construct. They go on to say that the sides, all of them, each of the 4 sides costs $6 per square meter. So each side costs $6 per square meter to construct. And of course, there is no top. So do you think that that sounds like a real life problem? I mean, wouldn't you expect the bottom to, in most cases, to cost a little more than the sides? Right? It has to support the weight. And now they ask me to find the cost of materials to make the container in the cheapest way possible. You guys are all ready for this, aren't you? What did they ask me to do if you took that sentence that I just said and paraphrase it? Minimize the cost. So, remember what we do. Y is the thing that we find the largest or the smallest of. So I'm going to let Y equal the cost of construction. Anybody want to help me build an equation here for Y? How much does it cost to build the top?
Nothing.
Thank you. Nothing. There ain't no top. How much does it cost to build the bottom?
10.
So I've got the cost of the bottom plus the cost of the right side plus the cost of the left side plus the cost of the front plus the cost of the back, and there is no top. Goodness, why, this seems to have something to do with the surface area of a rectangular solid. I wonder if we've ever seen that before. We have, haven't we? Okay. Well, what does it cost to build the bottom?
$10 per square
Well, what if the
meter.
bottom was 1 square meter? How much would it cost?
$10.
$10. What if it was 2 square meters? How much would it cost? $20. $10 per square meter. What if there were 8 square meters to the bottom? 8 times 10. So I'm going to take the area of the bottom times 10. So Y is equal to 10 times, well, what is the area of the bottom? 2x squared. Well, what does it cost to build the right side?
X squared.
Well, now wait a minute. How tall is the box?
We don't.
We don't have that yet, do we? So I'll throw in another variable there. There's the height of the box. So the cost of the right side is going to be 6 times the area of the right side. And what is the area of the right side? x8. How much does it cost to build the left side? 6xh. How much does it cost to build the front?
2xh.
Well, 6 times the area of the front, which is 2xh. I guess I'm making a capital H there. And I guess the cost of the back is the same, in other words, 12xh. So, as a cost equation now, I've got y equals,
Why is the cost of the front 2xh and the cost of the back's 12? Oh, you just multiplied it. Okay, never mind. Sorry.
oh, well, no, don't be, you answered it for me. I don't know you're part of my salary now. So y is equal to 20x squared plus 36xh. Where'd 36 come from?
You multiplied it.
Oh, I agree. The only trouble is we have 3 variables here. You guys don't know how to do calculus on 3 variables. Take Calc 3, you'll know how, but right now we don't. I wonder if there's any piece of information up here that we've not yet used that might allow us to find h in terms of x, right? There's maybe some information that they gave us that we've not yet used. The volume, look at that. They told us that the volume is 10. Well, the volume is 10, but we also know that the volume is x times 2x times h. So if we make a little substitution there, I guess 10 is equal to 2x squared h, or in other words, h is equal to 5 over x squared, isn't it? So let's substitute that into our equation here. Evidently now we can write y equals 20x squared plus 36x, and we will now replace h with 5 over x squared. Okay? So the cost equation, written in a way that will facilitate a derivative, is y equals 20x squared, what's 5 times 36? 180? Yeah. 180 x to the negative 1. So what would you do if somebody asked you to find the maximum of that equation? A derivative. I would have never thought of that. Oh yeah, it's a calculus course. Take a derivative. So y prime is equal to 40x minus 180 x to the minus 2. Now what? I need to take a derivative. It's a calculus course. Set it equal to 0. Oh yeah, find the critical points. So I'm going to take 40x minus 180 over x squared and set it equal to 0. Where did 180 over x squared come from?
X to the minus 2.
Oh, x to the negative 2. Very good, thank you for your help. What am I going to do now in order to simplify this equation?
Solve for x.
How?
Factor out negative 2.
All right, or multiply both sides by an x squared. So now I'm going to have 40x cubed minus 180 equals 0. So x cubed is equal to
40, no, 60.
which is 9 halves, isn't it? Is that right? Oh, I don't know.
180 divided by 40.
That's 18 over 4. That's, well, look at that, 9 halves. He's not a total idiot, he's mostly an idiot. Good thing I'm not as dumb as I am ugly. So what's x? Cube root of 9 halves. Well, do you think that that's a maximum? How can I tell without doing a sign chart?
Told you about that.
You guys remember something called the second derivative test? Remember, we talked about it right here on this board. I said if a comma f of a is a critical point, let's just say if f prime of a is 0, then what does the graph look like? Well, it either looks like this at a
That's
comma
right.
f of a, or it looks like this at a comma f of a, or it looks like this at a comma f of a, or it looks like this at a comma f of a. Those are the only 4 things it can look like. What did the second derivative tell me? What if f double prime of a is positive? What does that mean?
That prime was increasing.
concave up, so it was a minimum. What if f double prime of A is negative? Concave down, so that critical point is a maximum. What if f double prime of A is equal to 0? Then the test fails. Use the sign chart. Sounds like they're coming after one of you guys. Use the sign chart on f prime, right? Not f double prime. So this is a very easy derivative to take. Let's do y double prime. What is y double prime? Well, I'm going to use this green equation here. So 40 plus 360 over x cubed. Notice that y double prime of any positive number, in particular the cube root of 9/2, is positive, which means concave up, which means minimum, which is what I'm looking for. So we're done. X should be the cube root of 9/2. Give me a decimal approximation. I mean, if you are telling the person building the box to make it the cube root of 9/2 meters long, they're going to think you're nuts. So you would plug this into a calculator. There's the width. You would take 2 times that, whatever that approximates out to, and say there's the length. And then you're going to take, well, h is what, 5 over x squared? So then you're going to take 5 over x squared, and that will be, after you approximate it out, the height. So now you'll have the width, length, and height of the box. That costs the least to make. Questions?
Why does y double prime go from 4 plus 360 over x cubed to just 3 over rad 92?
3 over y prime 2.
No, the next step over, yeah. Why does it go to that, to the next step?
Well, I was taking the critical point and plugging it into the second derivative and observing it was positive.
Okay.
That's that second derivative test right there. See, if I have this